Like, ever since we had APIs and we had software, it was calling stuff on behalf of people. We've done this all over the place. We've done it long before OAuth was even invented. So what's the difference? Well, let's take a look at some of the classical ways that we've solved this problem. Now, how many of you here work in kind of traditional enterprise-y spaces? It's okay. This is a safe place. You can admit it. All right? Some tentative hands in the back group. I see you. It's all good. So one of the things you can do, and this is especially prevalent in enterprise environments, is that when somebody logs into your application, you just steal their login and replay it to an API because you know it's going to work. This happens all over the place, and it could be as clear as taking their username and password that they typed into your app to log in, and that logged in properly, and then you just turn around and replay that to the API. People did this all the time. People sometimes still do. The other thing that I see a lot of, which terrifies me even more, is people will steal the session cookie from the user and replay that in back-end services as if they're the user's browser. I see that all over the place, and it boggles my mind that people think that this is okay. And one of the reasons that people think this is okay is that, well, it kind of works. It works a frightening amount of time, especially when you're in these enterprise spaces where you've got single sign-on. You've done all of this work to set up a single sign-on, and you want a very clean user experience that the user just shows up and everything just connects together and it all just works. Now, one of the good things about this is that you know that you're accessing a specific user's account. That's great. But here's the problem with this. If I'm the protected resource, and let's say I'm going to pick on a couple of people in the front row here. All right, so let's say that, that you're our user, and you've written a client application, okay? So you're the user, I've got an API, you're going to come log into my API. Let's say we're just using username and password, just normal traditional HTTP basic stuff here. You're going to log into my API, I'm going to give you your results, I know that it's you, everything's fine. You've written a client application that uses this pattern. So he logs into you, and then you log into me using that credentials. Who do I think is logging in right now? Him. Do I have any way to know that it's this guy's application calling me? No, because we are doing an impersonation attack here. That's absolutely what this is. It is an impersonation attack that we are kind of okay with because it gives us some functionality until things go horribly wrong. And this is a really, really common anti-pattern in the world that OAuth was brought to try and mitigate. Another place that this really breaks, though, is when you start going across security boundaries. So let's say that now I am Google running an API, and you are Amazon running a client that needs to access my Google API. You've got an account with Amazon and an account with Google. They're not the same accounts. So you're not going to be able to log in with your Amazon account and he be able to replay your Amazon credentials and expect that that's always going to work to Google. Now, side note, yes, as a security engineer and researcher, I know that that actually does work way too often, but let's assume that in general it doesn't. We've got different passwords in different places, multi-factor authentication, all that other stuff like that. So what are you going to do if you can't just steal his keys on the way in? Exactly. You're just going to say, hi, can I have your Google password? And he'd be like, oh yeah, this sounds like a cool thing. You log into LinkedIn today and it still does this. It says, hey, give me your email password so I can import all your contacts. I promise I'll be nice and I promise I won't do anything bad, because that never happens. And on top of this, we run into a lot of the same impersonation problems. I have no idea that I'm actually sending all of this information to Amazon. I think I'm just sending it directly to this user over an API. And this works ridiculously, it works ridiculously well. The biggest problem that I have with this, though, is that we are training users to do the wrong thing here. We are training users to say, hey, when somebody asks you for credentials to a different service, just give it to them because you might get something shiny out of it. That is not what we want to be teaching our users to do. right? They need to be actively involved in the security process, and they need to be able to make these decisions that make sense. Because your users are inevitably going to make bad decisions for lots of different things. So let's stop teaching them how to make some of the worst bad decisions by giving them something shiny. All right. So we've got some massive problems with both of these. So let's say instead of using the user's password, what I'm going to do is I'm going to set up a key so that when this client application shows up, he can open the door no matter who's knocking. I give him a universal key. We do this all the time, especially in enterprise space. We call it an API key. And then we just throw a parameter on our API that says, what user are you acting on behalf of? And then I'll just trust you. And hopefully you guys can start to see some of the holes in something like this. Because there is nothing preventing that client application from saying it's acting on behalf of a different user. It's acting on behalf of a user who never used that client application, never showed up. There's no way to verify user presence or intent. There's no way to give notification built into the protocol. We are giving godlike powers to this one piece of software for all users that can access that API. And is Google ever going to give Amazon an API key for all users anyway? No. I mean, it's ridiculous. It would never happen. All right? So let's back away from, we've got these patterns, they're fairly common, so let's back away from them a little bit, and let's now create a new credential that represents our user and our client application. So instead of him giving me his password, or him giving the client his password, he's going to give the client a special password that says, not only is this for my account, this represents me, but this is a password that I know I only gave to this client application. So when that shows up at me, guess what? I can now tell the difference. I now know the difference between the user logging into me directly with their credentials and a piece of software, a specific piece of software coming to me with this service-specific password. Security properties of this are pretty great. So what if I'm running a banking API and he wants to be able to say, I want you to be able to read all of my transaction history but not make any transfers? Seems like that would be a useful thing to be able to limit, right? Or say it's medical information and I want you to be able to access this part of my record but nothing else. Maybe just my x-ray history, but not my psychological profile. There are lots of really very real use cases, but if we were using just the user's password, I can't differentiate because it's just the user. He has access to everything. I can't really gate that. I can't stop that. But in this case, I can. Because maybe when he creates that password and lets me as the service know about it, he says, this is the read-only password for my banking application. You can only do read stuff here. That's it. And so when that shows up, if he tries to do a write application or a transfer, I can say, no, you don't have access, sorry. When he shows up and be like, oh yeah, transfer all the money you want, that's cool, no problem. But I can now differentiate, and that's really cool. So what's the problem with this model? The security's pretty good. But the thing is, the usability really sucks. It's really kind of awful because now we're putting a lot of weight on the end user to go create this new password, to manage it, to copy it and paste it into the right place, and be able to put it into the application. It's really, really awful. And we know that it's awful empirically because this pattern has been deployed. One of my favorite examples of this was Google Code, if people remember that. So Google Code had, among other things, a subversion service for storing your code. And one of the things that you could do was create a special subversion password so that you didn't have to put your Google password into your subversion client, so every time you were to pull an update or push a branch or whatever like that, it wouldn't be broadcasting your Google password all the time. It was this special service-specific password. But you had to, in order to generate this, though, and to find it, you had to go into the Google Code website, into the accounts page on a special subscreen, and then click view your password and then copy and paste that. And we know for a fact that people got this wrong constantly. People were, Subversion was like, hi, you're trying to log into Google, because it doesn't know about all of this. And people are like, okay, here's my Google password. Why isn't it working? I'm going to try refreshing it 80 million times to see if that works. Meanwhile, it's broadcasting my password every single time I'm hitting this button. Or it's doing it automatically in the background. And the funny thing about this, though, is to think of the audience of Google Code. Software developers. Software developers largely working in teams. Really, really nerdy nerds, in other words, screwed this up constantly. And in spite of all of its great security properties, do we really expect normal people to do that? And incidentally, when I say normal people, I am automatically excluding everybody in this room that is taking 3 hours to learn about a security protocol on a Sunday afternoon. Seriously, regular users don't think about things like this. It's not going to make any sense to them. The model is really, really kind of foreign. So we're getting closer. We've got this service-specific thing. That's got some great properties. So let's fix the usability. Let's keep our security high, and let's make our usability better. So we're going to introduce a new component called the authorization server that's going to let us bridge the gap between those. Now, this is the thing that generates these service-specific passwords, and we're going to call them tokens. It's going to generate them for the client, and it's going to also be the piece that authenticates the resource owner. It's going to know who the resource owner is and how they log in, and it's going to also be able to authenticate the client. So when the client application shows up in this system, we're going to be able to verify its identity as well. And we're also going to be able to manage the authorizations of this client. And all of that gets distilled into an OAuth access token. This represents a transference of rights, a delegation from the resource owner to the client for the protected resource. That triangle that we were looking at before, the access token is what represents the fact that that delegation has been made. An interesting thing about OAuth access tokens, and this is different from other security protocols, is that the format of the token is opaque. So all of these are totally valid access tokens. First one's a random hex blob. The second is a type 4 UUID, so that's 112 bits of random entropy, assuming a good random number generator. The third one, does anybody recognize that format offhand? It's JSON. JWT, JSON Web Token, yes, that's exactly what that is. And we'll talk a little bit about JWT later, but that is a structured token format that you can use as an OAuth token, but OAuth doesn't care. The bottom one is a high entropy word list, and those are used in cases where you want to be able to memorize. We want a person to be able to memorize it. And OAuth tokens, people don't memorize them. So why would I ever do that? Because I can. OAuth doesn't care. I'm allowed to do that. If that is the best mechanism that I have for generating random tokens with high entropy, I can do that. OAuth will carry those for me. Now, I asked everybody before, who has used OAuth before? So I'm going to ask you to put your hands up again. Who has used OAuth? All right. So most of the hands went up on that. I'm going to ask the question a little bit differently. Who has ever logged into an application using Facebook? Who has ever done login with Google? Who has ever used Spotify or Steam? Who has a smartphone? Well, guess what? You've used OAuth, whether you knew it or not. An Android phone, when you turn it on, it is doing OAuth to talk back to Google. This is built into the core of the Android OS. iOS uses it all over the place too. I can't speak for Windows Phone because I've seen one in the wild. I don't know what it does. They use it. Okay. So OAuth is absolutely everywhere. It is everywhere. Anytime that you have seen a screen looking something like this that says, hi, there's an application that wants to do something for you, chances are these days you're using the OAuth2 protocol. Whether you're on a mobile application, whether you're on a web application, you're probably using the OAuth2 protocol in order to do that. This is the part of the protocol, as we'll see in a little bit, where users have a chance to be able to respond and participate in the security of the protocol itself. All right. Now, I think it's important that when you're learning about a protocol as it stands today, it's good to know where you're coming from, how we got here, right? You guys probably noticed that this is about OAuth2, which means that there was probably an OAuth1 at some point. And there was. So let's take a trip back to 2006. 2006 was a very, very different world on the internet. Anybody know the top website on the internet in 2006? MySpace. Nice. No, it was MySpace was the top site on the internet. The iPhone wasn't a thing. The App Store was a few years away. Android had been teased as something that looked weirdly BlackBerry-ish, and nobody quite knew what that meant. It was a very, very, very different world. And the way that we accessed APIs over the web, which there weren't as many, websites weren't really API-driven like they are today, but when there were APIs, you just asked the user for their username and password, and they would connect. Now, a couple of companies had come up with some clever proprietary systems tied very deeply to their protocols that allowed you to do that type of delegated authorization like we had just been talking about, getting that special token to the client application. They had come up with interesting ways to do that, called BBAuth, AuthSub, and there were a handful of others. The problem with these is that they were tied very, very deeply to the protocols that they were protecting. So if you were talking BBAuth, you were talking to the Flickr API. They were so intertwined with each other, you couldn't really extract them. AuthSub was Google's version of it for calendaring and I think a couple of other odd things. So this is the world that we're in. The problem is that we had a couple of sites that wanted to build up their APIs to be able to connect their users. We were starting to see API-driven websites and cool stuff like that. And they wanted to be able to talk to their users to be able to connect the services from one to the other. One of these sites was this little sort of bookmarking data site called Magnolia. It was a startup that has since evaporated. The other was this little news thing, Twitter, it's called. I think they're still around. The problem is that both of them were looking to use OpenID as logins, Magnolia especially, which meant that in order to access the API, there was no username and password. OpenID is a federation protocol. There is no username and password for me to copy. By design, I can't do that password stealing thing that we were talking about before. I'm not allowed to do that anymore. So how on earth am I supposed to be able to even connect these two things together? Well, a bunch of really smart people got together in the back room of the OSCON conference and figured out a way to extract the security bits from BBAuth and AuthSub into a common standard open protocol. And that was published, independent of any standards organization, as OAuth 1.0. Now, as is usually the case when a bunch of smart people come up with a new security protocol, a couple of months later, a really bad vulnerability was found in that. And that was published as the inscrutably named OAuth 1.0a. I don't exactly know why it's not 1.1 or 1.0.1 or anything sensible, but it's not. This was eventually brought into the standards community of the IETF and standardized as RFC6849. And what usually happens with standards like this is they get put up next to the shelf next to all of the proprietary solutions and all of the weird little solutions that engineers come up with. But that's not what happened here. People saw this and realized that it fit a need that they really, really had. Websites were really starting to embrace this, build an API and then build your site around it idea. The web, as we knew it, was changing in terms of its application platform. And the most mind-blowing thing about OAuth 1 was that Google, Yahoo, all of these companies that had proprietary solutions, they chucked their proprietary solutions and said, we're going to use this open standard instead, because it's better for our developers and it's better for our users to commoditize this layer of our application. Because what they realized is that what people really cared about was the API, was the application that they were building on top of the API. It wasn't all of the security stuff. That's just the stuff that gets in the way. And here's one of the first kind of pull back the curtain realizations that I want you guys to come home with from this, is that nobody writes OAuth code for the sake of writing OAuth code, unless you're me. Nobody does it, not in the real world. People will write OAuth code because they're trying to access an API. Or they're going to write OAuth code because they have an API that they want to protect. There is some other functionality that they want, and OAuth is the means of protecting that. And that's why it is so valuable to have a common and open standard here, because this allows developers to concentrate on the parts of the application that they actually care about and let the security work in a predictable fashion. Now, this got used all over the place, including a lot of places where it was never intended. And some of those places included this new thing called a mobile application. It was accessing a back-end API. Again, in 2006, that was less of a big deal. So OAuth was originally designed about a web server talking to another web server, and now people were using it on installed apps as well. Well, you could kind of do it, but it didn't really work very well. And people came up with some really weird hacks around that. Google deployed this at ridiculous scale, as they are wont to do, and realized that OAuth1's insistence on everything being a symmetrically shared secret is really, really hard to replicate across data centers. Now, today, with our microservice and cloud computing-based world, we know it's really, really hard to get a shared secret from one end to the other of these things in a predictable fashion. Really, really, really difficult to do that. So Google kind of tweaked the OAuth1 protocol in weird ways in order to make it work in their space. And the other thing that people wanted to do is that, we had applications that weren't about a user delegation. It was just software talking to other software. And if we're building our security APIs, or our API security rather, around this whole OAuth delegation thing, well, I'd like to be able to use that for this direct connection as well. But I couldn't do that because OAuth is a delegation protocol, and OAuth1 made a lot of assumptions about who was doing the delegating. So the community took a step back and decided to figure out what were the parts of OAuth that people were really using, what did they care about, and we codified those and tried to remove as many of the pain points as we could and add the extensibility points where we knew we needed them, and that came to be the OAuth 2.0 protocol. And that was ensconced in RFCs 6749 and 6750. Now, you can already see a major difference here because instead of one RFC, we've got two. The first one is how you get a token, and the second one is how you use a token. OAuth1 tried to do everything as a single monolithic protocol. Everybody did everything exactly the same way, which meant all of the different use cases paid the cost for all of the other different use cases. In OAuth 2, we realized that that wasn't working out for people very well. People were taking shortcuts anyway and breaking things in ways that were worse than had we built these assumptions in a little bit differently. But this does mean that OAuth 2 is not really just a single protocol. It is instead a set of building blocks, and a colleague of mine likes to call this a protocol generator. Because you've got a bunch of pieces and a bunch of recipes for deploying them in common ways, so that you get lots of code reuse and you get lots of common models. But it also does mean that you can have two things that implement OAuth that can't talk to each other, which seems really weird for a standard. We'll get into why that might actually make sense in a little bit. First off, and this is going to be the last section before our first break here, I want to talk a little bit about what OAuth is not. Because I think it's really important that people understand the boundaries of the protocols. OAuth does not solve all of your security problems. Sorry. It can solve some of them if it's applied well. But it's important to know where OAuth's definitions stop. Now, the first thing is that it's built on HTTP. A lot of the people that came together to build OAuth had been burned by the SOAP days, where you had all of these super abstracted data models that were just very tenuously connected to the underlying transports. And so you had these giant XML documents that needed to be processed, and it's just like, oh, do an HTTP post or something? I don't know, right? OAuth took a very different approach in both 1 and 2 and said, no, this is for HTTP. If you're doing OAuth over something that's not HTTP, it's not OAuth anymore. You're going to have to define how that works. Cool thing is, people have done that. So there are OAuth bindings for GSS API, which if you don't know, that's how email clients authenticate and other things on the IMAP protocol. It's used in a whole bunch of different places. And also the CoAP protocol. The CoAP protocol is you can think of it as a high-efficiency binary HTTP analog. So Internet of Things devices can speak CoAP much more efficiently than they can speak HTTP. So there's a lot of analogs in how CoAP works to HTTP, but somebody had to sit down and write and say, all right, so instead of sending an HTTP header, you send a CoAP core option field. It's the same thing, but somebody had to say, this is where you put it, this is how you do it, because OAuth was very strictly, this is HTTP bound. And I think that that's a good thing because it's made OAuth very predictable in how it works in HTTP. OAuth as a delegation protocol is all about delegating to a piece of software. It is not about delegating to another user. There are really important use cases for delegation between users. We see them all the time in financial. So I run a company. I would like my accountant to have access to all of my account history. I want her software to be able to call my API. OAuth doesn't allow me to do that. OAuth would allow my software to call my API, but not somebody else's. So in order to get that type of user-to-user delegation, you have to build on top of it. And the User-Managed Access Protocol, or UMA, which I gave a talk about last year, the newest version of the UMA protocol, so you can look that up on the Identiverse YouTube channel, allows you to do exactly that type of user-to-user delegation using OAuth as one of the components. Now, at the very beginning, we talked about OAuth not being an actual authorization protocol, and the reason why I try to be very careful about stating that is that there are authorization protocols out there like XACML and the like, which say, here's a thing that you can process, and it'll tell everything that you need to do to this. Everything that you need to make a decision is encoded in here. OAuth doesn't do that. It gives you a token. It gives you a handle. You can look up information using that handle. You can maybe parse it out if you're using JSON Web Tokens. But OAuth itself is just the carrier for that. What OAuth does is it gives you something that says a delegation has happened. How you figure out what has been delegated, OAuth stays out of that game because there are a lot of different ways to handle that that fit different use cases better. And like we talked about, OAuth doesn't have a token format in its own, but your tokens need to have something in them. So the client doesn't need to know what the token is, but the authorization server does because it's making the tokens. Your resource servers need to know what to do with the tokens because, well, they're the ones that are getting the tokens and have to figure out what they mean. So you need token formats, even if that format is, this is a random hex blob. There are a lot of different ways to do this, but OAuth doesn't specify any particular one. And this I have seen trip up first-time developers a lot, especially if they're trying to put together an authorization server side, because they're like, all right, time to make my token. What is it? What do I do? And this is one of the places where OAuth stayed very, very much out of that game. Unlike OAuth1, OAuth2 doesn't have cryptographic and signing mechanisms built into it. It relies on TLS for transport security between the endpoints. Funny thing is that OAuth1 had its own signature mechanism. It was fairly custom, and it was very custom and fairly complex, and a lot of people got it wrong and started turning off signature validation just to make things work. So we knew that that was a major pain point of the OAuth1 protocol. And so we tried to, instead we built OAuth2 to rely on TLS for protecting these tokens as they go all over the place. One of the other issues is that in OAuth1, people thought that since I had the signature method, I didn't need to use TLS. TLS was kind of an expensive thing in 2006. And why would I use it if I don't have to? We're slightly smarter as an industry these days, and we already know that that was wrong and that TLS really does need to be deployed everywhere. And if you want to know more about where this assumption falls a little bit short of reality, I'm going to be covering that in more depth in my talk tomorrow, because this is one of those things that it was both a good decision with some bad consequences about the OAuth2 protocol. And again, it's not a single protocol, so you can use OAuth in a lot of different ways. And finally, I get this one a lot. It is not an authentication protocol. Let me say that again. OAuth is not an authentication protocol. It is just absolutely not. We're going to go into more detail later on this afternoon about exactly why that is. But the gist of it is that even though it relies on authentication happening in a few places, at the end of the day, you're just saying this software can access this API. It doesn't tell you anything about who the user's there, how they got there, how they authenticated, any of the types of information that you would need for an authentication protocol. We're going to talk about the authorization code flow, which is far and away the most canonical way to use OAuth2. When OAuth was originally invented, it was all about one web server talking to another web server, and there's a lot of things that you can do to separate bits of information when using that. And so remember, these are the pieces of OAuth that we have to work with. The resource owner, the client, protected resource, authorization server, and we've got the access token that's kind of tying all that together, right? So this is the authorization code flow, and that's how it works. Everybody got that? Don't worry, we'll go back. In order to really understand how this works, we need to realize that there are two different ways that these different components can communicate to each other. One of them that should be familiar to just about any web developer or API developer is back-channel communication. And for that, you've got one piece of software talking to another piece of software using HTTP. So I make an HTTP request, I get back an HTTP response, I've got headers, I've got body values, I've got different verbs, I've got different URLs. It's very rich, very expressive, and it's point-to-point. So I'm talking directly to another server and getting something back from that other server. So there's a lot of things that I can do to make sure that I'm doing that. I can check the TLS certificates and all of that to make sure that I'm talking to the correct server. This is back-channel communication. The downside is that users don't talk HTTP natively. So when getting a user involved in this, which is what we're trying to do with OAuth, we can't use it. So we use the front channel. Now the front channel is a really clever way to communicate between two bits of software by using a browser as an intermediary. So I'm going to send a front channel request. It's going to go through somebody's browser and end up at the other side, and they're going to reverse that to get information back to me. In other words, what happens is the client wants to send a message to the authorization server. So the client is going to create a URL, and that URL is something that is hosted by the authorization server, and the client's going to add a bunch of query parameters to that URL, and it's going to tell the browser, go there. Now, if you're in a web server-based application, you do this with an HTTP redirect. If you're a native application, you use, intent.open or whatever iOS does that's a copy of intent.open. And you're going to do that in order to get the user in their browser to load a web page on another server. Now, what happens when the browser loads that web page? That URL, with all of its query parameters, goes into the authorization server. Now, the authorization server has access to all of the information that the client tacked on to that request without the client ever talking directly to the authorization server. And why is this important? Well, once I get the resource owner and their browser over there, as the authorization server, I can start having a conversation with them. I can say like, wait, who are you? I need you to log in, or I need you to present your second factor here. I can run all of my regular session fingerprinting heuristic stuff on you. I can ask you, is this really what you wanted to do? Because you've never made this decision before. I can have a conversation with the user and involve them in the security process. This is really, really powerful because this is all between the user's browser and the auth server without the client having to know anything about it. The user is logging in without giving any of their information to the client. The client has no idea who the user is. No clue at all. It's a really, really powerful construct. And to get back, well, the auth server is going to take a URL that's hosted by the client, and it's going to tack a bunch of query parameters on it and tell the browser, go here. So it's going to send a redirect back. The browser is going to load that, and that's going to send a request to the client application, and it can then read all of those parameters off the incoming URL, and that completes the front channel response. This allows us to separate the information of when the user is present versus when the user is not. And this is a really powerful thing for us to be able to do in OAuth, because a large part of our security model is about limiting access to information to the right parties at the right time. So now we're going to get into the deep nuts and bolts of how the authorization code flow works. Now, a lot of you have probably programmed this, or at least been exposed to it at some point. We're going to go step by step through this so that you guys can see exactly how every bit works and why it's separated out the way that it is. All right? Now, first off, the client needs to figure out that I need to get access to the protected resource. But I can't do it on my own. I need to get the user involved. They need to give me something so that I can go access it. Back in the day, this is where we would prompt them, hey, give me your password so that I can access the API. Instead, now we say, oh, go over to this other website and do what it says, and then come back with something, and then I can go access it. All right? So this starts our front channel transaction. Next up, we're going to authenticate. We want to know who that resource owner is. We're the authorization server now. We need to know who that resource owner is. We need to know who is doing the delegation, because this tells us what they're allowed to delegate for, who they're allowed to delegate to. All of this information is available to the authorization server. Note, none of this information is available to or needed by the client. Client doesn't need to know who the user is. Client doesn't need to know what the user might also have access to. Client doesn't even know if the user has access to the thing the client's trying to get access to. It just said, go try. So at this point, we can start having this conversation with the user. And since the user's there, we no longer have to rely on centralized, pre-placed security policies to make all of our decisions. We can ask end users, in the right circumstances, it looks like this is what you're trying to do. You've never done this before. Is this really what you want to do? This is a security concept known as gray listing. And I gave a talk last year on the details of how to use gray lists effectively. They're a really powerful security construct, but they can also go haywire in some really fun ways, at least fun if you're a security engineer like I am. But the important thing here is that this innovation here is what allows OAuth to scale to internet-wide the way that it does. Because we're allowing users to make the security decision, to make that consent decision in the context of being about to go do something. I click on a site and I say, log in with Google, and Google says, hi, are you trying to log into this website? And you're like, yeah, I just did that. The user is allowed to connect those dots in a way that makes sense. So the user has said that, yes, this is the site, they have approved it, we know who they are, they've logged in, and so we're going to send information back in the front channel, back to the client. We've kind of closed that loop, which means that we're going to send a redirect back to the client, and the browser now needs to load a URL that is available to the client. For web servers, this is really easy. For in-browser JavaScript applications, also pretty easy. For native apps, we'll get back to that, because there's a few tricks that will help us in that space. But with the authorization code flow, this is where it gets its name. The most important thing that you get back at the client is this thing called an authorization code. That authorization code represents the moment of the user being present and authenticated and having authorized the client's request. So the user can say, yes, you can have read access to my bank account. Maybe the user will say, I'm not going to allow you write access even though you asked for it. The user gets to make that decision. The authorization server encodes that decision, and hands back this handle called the authorization code, which goes back to the client. Now, the client can't understand that authorization code. So what it does is it just turns around and it hands it right back to the authorization server. Okay, so we just got it from the authorization server. Why are we doing this? Well, no, we didn't get it from the authorization server, did we? We got it from the browser. So now we need to go talk directly to the authorization server to see if this thing is any good and see what it's good for. We can't trust that intermediary to not have maybe monkeyed with things a little bit. Additionally, this allows the client to authenticate itself. It says like, hi, I really am this client. I'm going to present you with a secret or a key or something like that that proves that I really am this particular piece of software that the user thought that they were authorizing. So at this point, the authorization server can then go and look up the access code or the authorization code that came in, and it says, oh yeah, it was this user, and the user thought they were doing this client, and hey, that's the same client that just authenticated to me, so that's good. And I am going to create an access token and then respond with that. So the authorization code then gets thrown away, because that's just a one-time use thing, but the token is a bit more durable, or it can be anyway. And that gets handed back to the client. And remember, we're in the back channel here. So this is handed directly back to the client application, and it parses it out of the HTTP response. And it can then go and use that with the protected resource. At its core, this is the process that the OAuth protocol is doing in all of its different flavors. We're going to look at how that gets optimized in different ways in just a little while. But ultimately, this is what we're accomplishing. We are getting a token to this client application that it can then use to go talk to the resource server. Now, some of you might be thinking like, okay, there's a next step, right? The resource server then needs to take the token and figure out what it's good for. And the OAuth protocol says, I don't care, you're on your own. It does. It specifically left that piece out of scope. And as a consequence, there are a couple of different ways that that can happen. One of them is JSON Web Tokens, one of them is token introspection, and the other is just look it up in a database. So we're going to look at the differences between those in a little bit. But first off, yes?
Sorry, you use the word user a lot.
Yes?
I'm clear on what you're referring to in that flow.
Thank you. I'm being a little sloppy with my terminology. I apologize for that. By user, I mean the resource owner. Yeah. So the resource owner is conceptually the entity who has access to the API that we're trying to get the rights from. Colloquially, it's the user in their web browser. It is the person using the client application to do something, right? So in this class, it's a great clarifying question. User, resource owner, same thing. There are some subtle differences, some of them legalese differences in those terms. So the full and proper term is resource owner. Also, since we're on the topic, there's another bit of terminology that I know I personally tend to be a little bit loose with. And you may have heard me use the word flow a few times to describe this process of going back and forth, and like you go here, then you go here, and you get this token. Flow was the term that the community used when the OAuth protocol was getting developed. The actual specification doesn't call it a flow, it calls it a grant, an authorization grant. And they're completely identically equivalent. They are the same thing. When I say flow, when I say authorization grant, exactly the same thing. The important thing to take out here, though, is that all of this that we're doing with the authorization code here, this is one authorization grant type. This is one way to do an authorization grant. I have had a lot of engineers come up to me and say, why do we call this the authorization code? It's the authorization grant. Just call it that. But it's not. Because as we'll see, there are other ways to do an authorization grant. You are granting authorization using a process. That's what the authorization granted is the whole process of doing this. The authorization code is one mechanism to accomplish that process. So when I say flow, I mean authorization grant. It's the same thing. When I say grant type, or something like the implicit flow or authorization code flow, then I'm really talking about a specific type of authorization grant, a specific way to accomplish the types of delegation that OAuth allows us to do. All right? Great question. Any other questions before we go to the next bit? Yes?
I don't know if you're going to cover this kind of later, but does this change when you have the client authorization server and the protected resource all within the same ecosystem?
Okay.
Like if you have, do you know what I'm saying?
Yeah, I do. So I'll repeat and rephrase for the recording and whatnot, because I think it's being recorded. So the question is, does this change when everything is in the same ecosystem? And if I may pry the cover back a little bit, a lot of times that I get asked that, it's people, sort of the underlying assumption is, well, I trust everything in my ecosystem more than I would otherwise, so can't I take some shortcuts here? And my counter question is, why on earth are you trusting things in your ecosystem? Ecosystems are there to kill everything. That's what they do. They eat things. That's why they're an ecosystem, right? It's not a poorly chosen metaphor. Really, the only thing that tends to change when everything's kind of within a bubble is the fact that whether or not you have to actually ask the user if they consent, because maybe that decision's already been made. Cool thing, though, is that you can still go through this flow, and you have the user present. You know that they're there, you know that they're logged in, so you've got some proof that they are using the application at a specific time. The application is asking for specific kinds of access. So by going through this and just not prompting the user, you're still getting a lot of really, really good information about the state of your system for auditability, for intent, for limiting malicious actors, because a client would still have to get a user to redirect and logged in and all of this other stuff in order to, get them to do that, instead of sort of the traditional API key approach where it's just, I'm just going to be bad today and just call a different user that never showed up, that never used this application. So it gives you more information in your system to combat bad actors. It allows you to track user consent, and most importantly, it allows you to implement gray listing across your ecosystem, which means that there are going to be times when the user shows up and it's like, yeah, I know this client, I know this resource, I know what they're asking. The answer is yes. The user doesn't get to say no. Happens a lot. Really great to be able to do that. However, new developer in your group designs a shiny new widget nobody's ever heard of. It's going to go call an API in some neat way. Maybe it's still in your ecosystem. Maybe it's a piece of shadow IT. And again, I gave a talk on that last year. So the user is going to get to the authorization server, and the authorization server is going to say, I don't have a policy that deals with this. But the user's there. The question's being asked. So now, instead of just saying, I don't have a policy about this, so the answer is no, the auth server can say, hi, user, I don't have a policy about this. Is this what you're trying to do? And it can, maybe check to see if this is fishy. Have other people done this before? Has this user made this decision before? Maybe I want to email one of the admins that, a new app has just come online and people might want to know about that kind of thing. By still using this protocol, even when you have trusted applications, it gives you a very rich information set beyond just kind of the traditional, oh, we trust everything, so once the door is open, just everything flies. So there's a very long way around of saying that you can optimize the user experience in a lot of really good ways, but the protocol, the underlying protocol itself, really largely stays the same. The biggest change that you end up having beyond the user experience is how that protected resource verifies the token information with the authorization server. Because you can probably have a very highly optimized way, like a shared database or something like that, for them to just go look that up. And that's a very common deployment. Yes? Yes. hold that thought until we talk about dynamic client registration. So the question was, since the client is talking to the authorization server directly, there must be some type of enrollment. We're going to talk about how that can happen programmatically, because there's a protocol that allows us to do that. But in a lot of cases, it is done manually as well. So in the type of ecosystem that we were just talking about here, it would probably be done manually, like this is this trusted app, and if it does something bad, here's the list of people to fire, right? With dynamic applications, you're going to treat it, the security is going to be a little bit different. So there's a lot of different ways to do that. And there's also something in the middle, and that would be a self-service registration portal that allows you to do that kind of stuff. Yes, one more before we move on. Okay. Yeah.
Database owners, they don't want to do regular security by username or by group. That's a pain in the butt.
Okay.
From a app perspective, says you have to store procedure. They don't want to use procedure.
Okay, I'm going to cut you off because we're not here to talk about database security. I'm sorry.
No, but just in general.
Right.
They don't want to protect the resource by user. What's your argument against it? Saying this is a better way to do it?
I don't understand the question because what you really have to do, if you're using a database or a service or something to look up information about the token, the resource needs to know like what the token is good for. And that needs to be able to be mapped to your underlying data store in some fashion. That's where the authorization processing comes in, which OAuth doesn't give you. So yeah, it really doesn't care about stored procedures or per user row access or anything like that. Absolutely irrelevant to the OAuth protocol itself. It doesn't care how that happens. So, all right. So, what we've talked about so far is how you get an access token. One of the coolest things about OAuth is that the access token keeps working once the user's gone. Think about that process we just went through. The user was there in the front channel. We went there, we went back, and then as soon as we got back with that authorization code, we were talking in the back channel exclusively. We went and got our token. We went and started using our token. The user could wander off. The user could go get eaten by an alligator. We don't care. We've got an access token. We're good. And that type of offline access is one of the original goals of the OAuth protocol, because you don't want to have the user constantly there in order to access APIs on their behalf. So what do we do, though, when our access token stops working? Maybe it expired. Maybe the user revoked it on us. Maybe a sysadmin said, that database is looking funny. Maybe somebody said, we fired Brian Campbell and we're just going to revoke everything from him. Hi, Brian. And we're just going to get rid of all of his access tokens. Watch, he's going to take a terrible picture of me now. What do we do about that? Cool thing about OAuth is that the recovery mode for an access token not working is you just go do OAuth again. Your client has everything that it needs in order to get the access token in the first place. So what you're going to do is you're going to go do that again. And this works great if the user's still there, if they're still logged in. If, like, the next time they show up, you're trying to refresh their profile information or something like that, great. Pop them over to the auth server, they logged in. Maybe we remembered that they made that decision. And so they don't even get prompted with anything, and we just get a new access token, and that's great. But what if the user's just really not there anymore? What if the user is offline? We find out in the middle of the night, we're about to go do, batch updates of all of our profiles and stuff like that, and all of our users are offline. They're not present in our app anymore, but we need a new access token. Do we have to wait until the user comes back? Well, in OAuth 1 you did, but in OAuth 2 we have this cool thing called a refresh token. And what a refresh token does is it allows you to get new access tokens. You issue it right alongside the access token, and it's only good for getting new access tokens. So the client sends it to the authorization server and basically says, hi, I need a new access token. Cool thing about refresh tokens here is that they're not good for getting any user data. You can't call protected resources with it. They won't know what to do with it. Additionally, they have to be presented along with the client's credentials. So we talked about the client authenticating when it's talking in that back channel. Well, the refresh token has to be presented along with the client's credentials, just like the authorization code would have been. So the refresh token can only be used to get new access tokens. And once I get that access token, I can then use to call that protected resource. Another cool thing about the refresh token is that we can now differentiate between a user's initial process and subsequent tokens down the line. Because maybe the first time we get all of their information and we can kind of like pull all of their APIs and stuff like that. But maybe this refresh token is only good for telling me, like, has this changed or not? You know, maybe some little flag here or there's just a tiny bit. The new access token that we get might only be good for some subset, small subset of that API that we want to access. We have the flexibility with the OAuth protocol to do exactly that with the refresh token, using a very, very simple mechanism. So let's talk about scopes. Now, who here has heard of what an OAuth scope is? A lot of people that have worked in OAuth2. Now, if you've got a naive API, you just say you can get in, you can just do whatever. Think back to the whole stealing the keys problem that we started this class with. If you can log in, you can do everything on that API because it's the API. The world is just completely open to you. That was the world that OAuth1 allowed you to do. In OAuth2, we introduced this concept of a thing called a scope, which allowed you to programmatically limit the access that a particular access token would be able to do. So let's go back to that banking example. Say I've got something that has an API that has two scopes. One that allows me to get the type of sort of summary information, your transaction history, and another one that says transfer money. Maybe I have another scope that says transfer money above $1 million. I can split all of those up into different scopes, and so that when the user authorizes their application, they can authorize it for, no, you can only get transaction history. Or you can do transfers, but only up to this limit. I'm not giving you the scope that lets you do absolutely everything that I, as a user, am allowed to do. So this is where the scope concept comes in. One of the funny things about scope in OAuth2 is that it can mean different things, ultimately. A lot of times, it's the kind of access. So are you reading? Are you writing? Are you deleting? What kind of action are you doing? Another thing is what type of resource. Do you have photos? Do you have the metadata about the photos? Do you have both? There are different sensitivities around those, right? So as a side note here, because I find that bringing this up surprises a lot of developers, so let's talk about photos themselves. So a lot of people think that, oh, it's the content of the photos, that's the really sensitive information. But if your photos are geotagged and date tagged, then suddenly I've got a nice map of where you are in different times and places. And so whenever anybody says, oh, it's just metadata, yeah, they're full of it. Because it's the metadata is where the real rich value is. So sometimes it's even the time of access, if the user's online, if the user's offline. And in OAuth2, scopes really just represent fundamentally what the token can do. It can take a lot of different flavors. And if you want to hear some ranting about how that went really weird in practice, again, come to my talk tomorrow where I tell you everything that's broken about OAuth. But the way scopes work in OAuth is it's just a string. It's a string that says, here's something that represents what this token is good for. It's completely up to the authorization server and the resource server what that means. OAuth doesn't define any standardized scopes. And the resource owner gets to approve the scopes, and the access token represents those scopes. All right? So any questions on refresh tokens or scopes before we move into the next bit?
So you said that the refresh token must be presented with the client's credentials.
Mm-hmm.
Does that mean the client has to cache my user credentials in order to
Fantastic question. So the question was, since the refresh token needs to be presented with credentials, does that mean the client have to cache the user's credentials? Well, think back to the authorization code flow. Does the client ever even see the user's credentials? No. The credentials I'm talking about here, and this is an unfortunate overlap of terminology here. The credentials I'm talking about are credentials that represent the client software itself, right? So it's the client's credentials that it has to use in order to be able to use that refresh token to get new access tokens. Because I don't want somebody else taking a refresh token and just minting new access tokens with no user involved. This is kind of a trusted, this is an elevated trust because we no longer have the user directly in the process to be able to say, no, that's fishy, right? So we need a little bit more trust than we would normally have with the regular OAuth flow because the user's just not in the loop directly. So yeah, so the answer is no. The client never sees the user's credentials, so it can't cache the credentials, and therefore it doesn't need them. And we're about to talk about ways where those assumptions and those good design practices can get broken. Because I mentioned at the beginning of the class that OAuth is really a whole it's a whole stack of different kinds of protocols that come together to solve similar but different use cases. All right? So the canonical use case is one web server talking to another web server. This is the authorization code flow. But what if you've got different kinds of clients? What if you've got different assumptions about the delegation itself? In OAuth2, we tried to come up with ways to optimize different pieces of those. We did better in some ways than we did in others, as time has borne. And again, ad for my talk tomorrow. We're going to be talking about all this stuff. But today I'm just here to talk to you about what they are and how they work and how they were meant to be used. So the implicit flow is where we're going to start. Now, the implicit flow was designed as an optimization of when the client lives inside the browser. The authorization code flow is all about keeping those bits of information separate from each other so that the client never sees the user's sessions, they never see the user's information like that. The browser never sees the client's identity and its secrets and all of that other stuff. But when your client software is running directly in the browser, a lot of those walls fall over. You know, a lot of those assumptions go away. So the implicit flow was intended to be an optimization for this case, and it uses only the front channel to get an access token. What this means is that I send a redirect over to the server, and I get a token back directly, which I can then use to go call the protected resource. So in a way, you can think of the implicit flow as a way to do kind of cross-domain cookies sharing, right? Because if I have a session with the authorization server, and I need to be able to, and I'm going to have a session in my, single-page application kind of thing, and I want to be able to call an API over there, I don't want to have to steal that cookie and replay it. We're trying to get away from that. But if I can just pop the user over there really quick and get back an access token, then I can call that API without leaking any of those primary credentials or even the secondary credential of the cookie itself. And this is a powerful pattern. This is allowing us to use OAuth in a way that is optimized for this space. The biggest problem with the implicit flow is that it is so simple. Developers see this and they say, oh, I'm just going to use this instead of doing all that authorization code stuff. What is that? I don't even know why. Why am I jumping through all of these hoops? I'm just going to go do this instead. Problem is, the implicit flow, when used correctly, isn't very secure. It's susceptible to impersonation and injection attacks. It's susceptible to some fun session fixation type stuff. And when it's used incorrectly, it is wildly insecure. If anybody in this room, and I am not going to ask you to raise your hand on this one, but if anybody in this room is using the implicit flow on a native mobile application, stop immediately. Your access tokens are fully interceptable by any application developer in the world today, full stop. No way to fix it without not using the implicit flow, because it was never meant for that. It was meant to only be used in this very limited case when you're inside of a browser. The problem is, it's simple. And developers like things that are simple. So a lot of people gravitate to this instead of trying to figure out how all of the different bits of the authorization code flow work. But if you're in this space today, it kind of makes sense as long as you stay within the rails. Yes?
So just real quick, to make sure I understand, you said that there's only one case for implicit, and that's JavaScript app in the browser.
That's correct, yes. Only one case for implicit, and that is a JavaScript app in the browser. And honestly, these days, that case is under attack as well, because there are even issues with it in that limited space. In that limited space, if you ask me, you can manage it. You can make some assumptions, make your tokens super short-lived. There are no refresh tokens because, remember, a refresh token's about when the user goes away. And with this kind of app, if the user goes away, the app goes away. It's just, they're not there anymore. So you don't need a refresh token. It doesn't make any sense. So there are some things that you can do that mitigate the security risk if you go through with eyes open. They can actually be made better by using, you can use the auth code flow in a browser. It works. Yes? Thank you for the segue. Because if there is no explicit resource owner and it is just the application acting on its own behalf, you're combining things, but instead of shoving things up into the browser, you're now taking the resource owner and cramming them down inside the client. So the client's really acting on its own behalf. So the implicit flow is completely not applicable here because there is no browser, there is no user, there is no person. We have software that is acting on its own behalf and software that can identify itself. If you have that, and then basically we're back in the world of API keys. And API keys still make a lot of sense in a lot of use cases. Not every access to an API is going to be delegated on behalf of an individual user. But that's what OAuth itself solves. So how do we kind of get around this? Well, we say that the client is its own resource owner. And since the client is its own resource owner, well, we don't need the front channel anymore. We can live just in the back channel, which means the client authenticates for itself and it gets an access token. And is that the type of situation that you were asking about?
Yeah. Where I work, we don't use this a lot. They keep a lot of our API data management.
Okay.
I was kind of curious as to why this is better than just standard JWT token.
Okay. So the question is why the client credentials flow is better than a JOT in this case. It's not a one is always better than the other. There are trade-offs in this space. The thing about JOTs is that they are documents that describe what they're good for. Fundamentally, that's what they are. They are assertion documents. And the thing about an assertion document that tells you what it's good for means that if you decide that that document isn't good for that anymore and the document still says that it's good for that thing, well, you're still going to let the document be good for that thing because it said it was okay. And it was okay at the point that it was made, so you're kind of stuck with that, unless you're doing an online verification lookup, at which case, why are you carrying all that information around in the document if you're just going to look it up anyway? So all of that, though, that's just about the format of the token itself. And we'll talk about token introspection briefly in a little bit. What's happening here, though, is how do we get that token? How do we get that token into the client application? So even if you're using JOTs to carry this, how does your client application get the JOT? Somebody pasting it in? Was it calling a special API to get it? Like, if you want to be able to do it automatically, and you want to be able to rotate this API key regularly, have them expire with short, reasonable windows, this is a really good way to do that. Because let's compare this to the classical API key, all right? So in the classical API key, the client is talking directly to the protected resource, and it's saying, that little blue key up there, it's saying, hi, I'm this client, let me in. we're effectively doing the same thing here. The client is getting something that says, hi, I'm this client, let me in. But here's the main difference. The protected resource no longer needs to know the client's authentication credentials. It doesn't need to know the client's API keys anymore. All the protected resource needs to know is how to look up an OAuth token. And you can use JOT to do that, as you were just saying. You can use token introspection to do that if you need a more lively thing. Or you can use databases, as we were talking about before. There's a lot of different ways to look up what an OAuth token is good for. And here's one of the best things. In addition to not having to manage your client credentials on all of your protected resources and API endpoints, which leads to people doing things like putting LDAP servers for software applications onto their networks, which is just all kinds of weird. Your resource server will now be able to take in OAuth tokens that are for clients to act on their own behalf, as well as clients acting on behalf of a specific user. So let's dive back into the enterprise use case time card information. If a client is working on my behalf, it should have my time card info. I should be able to get my time card. I should be able to update it, all of those types of things. If, however, I am the script that HR runs at the end of the week to collate everything and send out the billing to all the right projects, I don't want to have to get permission from every single user to get their individual time. I want to be able to say, just give me the time card info. Just dump it out right now and go and do its thing. That's what this is for. But that protected resource in both cases will get an OAuth token, and it says, like, oh, you're trying to use the get all the time card information call, and, oh, wait, this is only one user. Yeah, no, you're not allowed to do that. And by the way, security team, call this guy. But if the HR thing is trying to like muck around with an individual user, they're probably not going to be doing it in that way either. So you can really limit what each use case is just by using the mechanisms that are already built into what an OAuth token is good for. It's a really powerful thing to be able to do. All right. And now we're going to talk about one of the most fun ones, and that's the resource owner password flow. Now, for this grant type, we're going to codify the anti-pattern of stealing the user's password, or really asking for it, and we're going to call that OAuth. I'm not joking. This is how it works. What you do is the client application says, hi, can you give me your username and password? And then instead of turning around and handing that to the protected resource, which is what we used to do, it turns around and hands that to the authorization server, and it says, can you give me an access token that's good for whatever user this represents? And then you get an access token that you then use to call the protected resource. Now, this obviously has a lot of the same problems as asking for the password in the first place. The client is exposed to the user's credentials. Maybe the client's going to cache the user's credentials, like got asked a few minutes ago, because nothing's stopping it from doing that, because it sees them, right? And we're still kind of teaching users that when an app asks for your login, just give it to it, and that's fine. Not necessarily what we want to be teaching people. However, this is marginally, and it is a small margin, but it is marginally better than just calling the API directly for two main reasons. One, your protected resource now no longer needs to know the user's password. Previously, the client had to know the user's password, and then the protected resource needed to be able to not only see it, but also verify it. So you needed to have some type of system in place to do that, maybe LDAP or something like that. As an aside, how many of you here have thought about the way that LDAP actually works? LDAP-based authentication. You get a user's username and password sent to you in plain text. Sure, maybe you're being good and you're using TLS, but you get the password in plain text. And then you replay that on the LDAP protocol to the LDAP server to see if it works. Basically, that's somebody handing you their keys and you trying it in the lock to see if it actually works, to say, oh yes, I believe you, this was your key, right? It is, by design, a benevolent man-in-the-middle attack. You're sitting right there and saying, like, give me your credentials, I'll see if they're any good, and we're going to go on our day. That's how LDAP works for authentication, and that's why a lot of us are getting away from that model and onto federated identity systems. So this at least gets the protected resource out of that business. The authorization server needs to be able to manage this back-channel thing, which means that we can now not do heuristic authentication. We can't do, sort of live multi-factor kind of stuff, because the protocol is all going over the back channel, and if we were to add a multi-factor thing, then we would have to modify all of the clients in order to be able to prompt for that and send that along as well. And we built this in the OAuth protocol to really be very limited, non-extensible, and say it's just a username and a password, because we didn't want people to use this. This was meant to be a stepping stone to allow people to get their protected resources onto OAuth and eventually get all of their applications onto OAuth. Unfortunately, these days, again, developers see this and they say, hey, this is simpler than doing the authorization code flow. Or more egregiously, people are developing native applications and say, I just don't feel like opening a browser. Or our UX people say, I'm not allowed to open a browser because they want to control the exact pixels on the screen because somebody got an art degree. And therefore, I'm not allowed to interact through the browser. I have to do everything natively, so this is the only thing I have to do. Those are all terrible reasons to do this, because the downsides of the security of this model are just absolutely enormous. You should not be using the resource owner password flow in 2018. You really should not be. Because at this point, OAuth was ratified in 2012. You shouldn't have legacy applications that don't know about OAuth. I mean, yes, I get it. The real world, we do. But come on, guys. You shouldn't be building new stuff at all. Because stealing the credentials is bad. Ultimately, that's what we're trying to get away from. This is a very small step away from that, but, it's still doing it. So now I want to talk about the assertion flows. The assertion flows and, to some extent, token swap. So these are things where you're doing, it was mentioned, just using JSON web tokens before. If you've got a trusted third party sitting on your network somewhere that says, this piece can talk to this piece at this time, and it issues a decree to the network, then that's a good case for the assertion flow. Because you've got this central authority that basically says, these two things are allowed to do the following actions. And what the client does is it takes that assertion that it got handed, and it hands it to the authorization server, and it comes back, and it gets an OAuth access token. Now, again, the cool thing here is that this protects the protected resources from knowing anything about all of this assertion madness. Let's say you were unlucky enough to have invested heavily into WS Trust or some other similar madness. You can protect your API and client developers from all of that insanity by using this as a bridge between the two systems. Large-scale enterprise providers who, for Microsoft's sake, will remain unnamed, really like this stuff because it allows them to very deeply centralize all of the decision processes. Because you now have this assertion provider that sits in the network, and it is now a higher authority than the authorization server, which is now just in service to that. It allows you to centralize all of those policies, and it just kind of chains down from that. Yes? The question was, would you use this in place of SAML? It depends on how you're using SAML. If you're using SAML as a login-based system, then no. if you're using SAML as a between application authorization, this would allow you to bridge SAML to OAuth, because you could get a SAML assertion in and then trade that for an OAuth access token and then hand that down the line.
Is this SAML then, if you're using SAML as the assertion?
Yep, exactly. So more properly, there is an RFC. It is 7524, I think, that tells you exactly how to take a SAML assertion and turn it into an OAuth access token. There's another one that says how you take a JOT-based assertion, which is SAML with curly braces, and turn that into an OAuth access token. And the fun thing here is that somebody realized that down the line, the OAuth access token that you get back could also be a JOT. And therefore, you can start doing some really funky, very, very complicated token chaining, swapping stuff with using this basic mechanism. So you don't see the assertion flow very much in the wild. The reason for that is that it's really complicated to set up and manage. You need a lot of other running pieces, and you need to have multiple very powerful components on your system. So no longer do you have the authorization server, which is kind of like your security cornerstone, so you can monitor and lock that and know what's going on with that. You now have your assertion provider, which basically can boss the authorization server around as much as it wants. So there are some definite downsides in terms of the complexity that you get from this. There are use cases, though, where this kind of does make sense because it allows you to bridge into the more sort of simplified token-based OAuth world from the complex assertion world. All right. So now we're going to talk about the device flow. I should back up and say that the first four that I talked about, the authorization code flow, implicit, client credentials, and resource owner flow, those are all defined in the OAuth RFC itself, 6749. And yes, if you hang around the standards world long enough, you start talking in 4-digit numbers like I do. The assertion flow is defined in its own suite of RFCs. There are 3 different RFCs that define the assertion flow. And then the device flow is its own RFC that is in process of being published right now. So this I wanted to point out because this kind of tells us a little bit about the flexibility of the OAuth core protocol. We've got this basic idea that there's a way to get tokens, but you can add other ways to get and use tokens. And that's a pretty cool thing to be able to do. So the device flow is all about limited interactivity with the client application itself. So say you've got a set-top box. You don't have a full browser with a keyboard and user sessions and all this. Or say you've got smart socks. You know, I don't have a browser on my socks yet. Somebody's going to get there, but we're not there yet. Until we get there, the device flow lets us bridge this by splitting up the OAuth process. It's very similar to the authorization code flow in that there's kind of a front channel and there's a back channel, except the front channel is discontiguous. Because I can now no longer just say, hey, browser, go to this URL. But what I can do now is I can tell the user, yeah, go to this URL, maybe it's printed on the case, and enter this code. Either I'm going to display it, or I'm going to beep it, or speak it, or something. Just go to this URL, enter this code, scan this QR code, do something like this on a device that has a real browser that you can log in with. So at that point, we're back at the authorization server, and the user's logging in, they're interacting, and they're now giving this user code, it's called, to the authorization server. Well, the authorization server knows about this because what's happened is that device has, in the background, gone and basically pinged the authorization server and says, hi, I'm about to send somebody over to you, and it's going to get back a code where it will identify itself and a code that it can hand to the user. So the user goes over with their code. The authorization server looks that up and says, oh yeah, I just gave this out to this device that said that they were going to show up with this. Great. And then it just tells the user, yeah, it's authorized. Your device will catch up eventually. Meanwhile, the device is going and pinging the authorization server like, hey, that device code, are we good yet? Can I have a token? Can I have a token yet? And it's polling the authorization server. And eventually the authorization server is going to come back and say, yeah, the user came, entered their code, everything's good. They said they approved it. Here's your access token. At that point, we're just doing plain old vanilla OAuth from that point forward. Or it's going to come back and say, yeah, your user never showed up. Your device code expired. I have no idea who you are anymore. Go away. If you want something, go bug a user again and try again. And the coolest part about this is that this device flow kind of breaks apart some of the initial assumptions of how OAuth even works. One of OAuth's biggest innovations is that it's using the front channel to connect a user's session with the application that they're using, the client application, and their session with the authorization server, without crossing the credentials between those. The device flow accomplishes something very similar without making that same assumption. And so to me, I find that really, really fascinating. In fact, I got to work with a client on a way of using this to serve disadvantaged populations that don't have full-time internet access. Because if your protocol relies on you being able to just redirect to a server and come right back without sessions timing out and stuff like that, a lot of stuff falls over. So what we were able to build instead was we used the device flow, and we generate this code, and it basically says, okay, when you can get online, go bring this to an onboarding location, and we will sort of onboard this device into the system. And we can do that pretty automatically at that point because we have all of the parts, but we just could not rely on them being able to go in a browser and authenticate and everything like that at the same time. So really kind of a powerful twist on things. Okay. Now we're going to take a little bit to talk about native clients, and I think this is the last section before the break. And all my slides are upside down. That's fun. I have no idea why that happened. All right. So we're going to talk about native clients, then we're going to take a quick break. Yes? So the question was, are there any best practices on persisting an access token or refresh token? Persisting by which part of the system? For the client. What kind of client? Okay, what kind of client? Is it a JavaScript client? Is it a web server? Is it a native application? It's a web server. So store it on the web server itself away from the user's browser. Backchannel storage away from the user. Don't keep it in the user. Don't ever expose it to the user. Because if you're going to be doing it on the web server, you're going to be making that call in the back end. Beyond that, that's database security. Talk to this guy. Yes? So the question was, how do you lock down an access token with a native app that you don't really trust? Today's mobile platforms have per app secure storage that's built into the OS. And so, if the question is about, the question really kind of comes down to, how do you not trust the native application? Because if you don't trust the native application enough to call your API with an access token, why did you give it an access token? You shouldn't have. Ultimately, if software is being authorized to call the API with this token, it's got to hang on to it in order to be able to do that. There are best practices per platform about how to best store secrets. And like I said, today those are built into the OS. I don't recommend using global variables or plain text storage or things like that. But both iOS and Android have system-level secret vaults that you can use that at least keeps other applications from getting your access token. More importantly, on both of the major platforms, there is the AppAuth library, which handles all of that for your application, so you don't get to screw up your own secret storage. You just say, get an access token, and it does those bits for you.
I guess what more specifically I'm asking though is there is danger in that application having that access token and being stolen by somebody else gets the device, right?
Right.
Steals it. Is there a best practice, I think back to his question on how long you make those access tokens live?
Mm-hmm.
Less trusted applications.
Gotcha. So the question is, like, say if the device is stolen, is there best practice about how long the access tokens live? So the real question you need to ask is, how much are you willing to take off your users? And I say that because if the access token expires and the refresh token expires, then the user needs to be then re-involved in the authorization process. And generally speaking, when users are using a native application, they expect it to be once and done. Like, I've already said that this is my phone and this is my thing, and therefore, just use it, just do it. If you are using the platform level secret storage for holding your access tokens and stuff, then those don't have to be, but can be protected by the local biometric authentication that's built into a lot of smartphones today. It's a vault that somebody has to unlock with a secondary credential that your application doesn't have access to. Often biometric isn't always. So that's a really good way to keep that from getting stolen by other apps or by a user who just has the phone, because they won't be able to use the phone as it has been provisioned. Another thing that you can do is that you can monitor for anomalous activity on your API, which quite frankly we should be doing anyway. And if somebody's phone in their account is doing weird stuff, maybe throttle that access token, maybe send up a red flag, maybe just revoke it outright and say, yeah, we need the user to re-authenticate this now because we are suspicious enough of this going on. In practice, a lot of the best practice for the expiry of access tokens is really about how long do you think you're going to need to continually access a given API. Make your access token just a little bit longer than that. So say you've got an app that, the user starts it up, and it's going to go pull refreshes of everything like that, and then maybe over the next 2 minutes, it's going to kind of poke things a little bit as the user does things. But the normal session, that's probably it. In that kind of case, I would say, again, these are all round numbers. Make your access token live for about 5 minutes, because then if somebody has a slightly longer session, you don't have to do any extra work. But when somebody shuts down the app, that access token's going to be going away. And your client can proactively throw out the access token when the user backs out of the app anyway. Especially if you have a refresh token, which again, you should be putting in secure storage, so that when the app is opened and activated by the user, and only by the user who either possesses the biometric or knows the shared secret to unlock that secrets vault, then, and only then, can you go get a new access token. And all of this is done without bothering the user to go and re-authenticate. But you still have the option of, when you think things are looking kind of fishy and you really don't trust a specific instance of an app, then yeah, chuck the tokens, by all means. That's one of the really powerful things that OAuth gives us above shared passwords. Because I can throw out an OAuth access token whenever I feel like it, and clients need to be able to handle that. If I decide to tell you that your password is no longer valid because you accessed your bank account too many times today, that's going to lose you customers and users very quickly. So it really is a usability problem as much as it is a security problem. Did that answer the question? All right, thank you. All right. Yes?
So earlier you're kind of hating on the implicit flow.
Yeah.
And saying you should use the client credentials and authorization code.
Authorization code flow instead of the implicit flow.
Right.
In a lot of cases, yeah.
So how do you protect the client credentials then? It's on like an untrusted system.
I'm glad you asked that. Because with a native application, for example, again, you'll remember this is one of the places where people say, hey, I should just use the implicit flow. They're wrong, and my most read blog post is about why they're wrong. But on a native application, I put this up in an app store. I'm going to download it. It's going to have a copy of the client credentials. You download it, you download it, you download it, you download it, you download it. We all have a copy of the client secret. How secret is that secret now? It's worthless. It's not a client secret. So native apps like this, they run on the user's system. They're really bad at keeping secrets, especially keeping secrets from the user. So even the access token, even if you're doing secure on-device storage and all of this other stuff, I could still get the access token. There are ways to pry that out of the system. There are ways to make it really hard, especially for a non-privileged user, just like another random application on the device, make it really hard for them to do that. That's great. Use that. But ultimately, you're not going to keep a secret from the user that's, running the device, that has legitimate access to the device. So because these live outside the browser, it's also really hard to get back to them, unlike the implicit flow, which lives inside the browser. So let's talk about how we can deal with those secrets. In OAuth2, it was assumed that every client had a shared secret, the client secret. This was a deep part of the cryptographic system that OAuth2 used. In OAuth2, we said you can either dynamically register this type of client, so every time a new instance of the client shows up, it talks to the authorization server first and gets a brand new secret that no other copy of it has, and then it goes on its way. That's really great, but there are some management costs to doing that because you now have all of these different instances that you've got to track. It's doable. It's a little bit of an overhead. But OAuth also said you could have just a public client that has an ID, and it's going to be the same copy of the ID, but no secret at all. This is how in-browser implicit clients work. Because they're only using the front channel, they only have a client ID. They don't have a client secret. There's no place to put a client secret in the implicit flow, which is another one of its fallbacks. But again, if you're shipping something out to the browser, that's not really a good place to necessarily store a client secret to begin with anyway. Now, we're going to get back to the secrets in a sec because for all of this to come together, I first need to talk about how we manage redirect URIs on native applications. OAuth was written for web server type clients, and the web server type client is going to have URLs that it serves. Makes total sense. However, I'm not running a web server on my phone, usually. Sometimes. It's much better for me to be able to get back to my client application using a native client URL. Now, I could run a localhost web server. Desktop apps tend to do this. Mobile apps, less so. I could use a remote host with push notification, but it's a lot easier for me to just register my client and say, hey, when you see something that says my app : / whatever, send it to me. Send that URL to me. This is why this works in the OAuth world, though, because this is a front channel communication. That means that the authorization server doesn't need to be able to call that URL. The browser does. The authorization server redirects the browser and says, go call this URL. I don't care what happens or how you do that, just go figure out how to call that URL. And that loads up, ostensibly, your native application. Here's where it starts to get fun. Because your app needs to register for that namespace. And any app can take any namespace at all. Completely wide open. So I can take the, com.capital1 namespace on my app when I install it. Totally cool. If you've ever seen a little pop-up on your phone that says, hey, do you want to open this thing or this thing? That's what's going on. The OS is trying to figure out, I've got two things that want to be able to serve this URL. Which do you want to send it to? Do you want to send it to real banking app or I'm totally not fake banking app? You pick. And as a user, I would argue you should have that right to choose that. Trying to regulate that at even the App Store level is just going to lead to false sense of security. Used to be even worse, though, because on iOS at least, in previous versions, whatever app got installed last is what got the URL scheme. I kid you not. So if you did a drive-by download of a malicious app, it would just sit directly on top of all of your stuff. So let's take a look at what this means for the implicit flow, though. The implicit flow does everything in the front channel, which means that the token is coming back on that redirect, which means that the token is attached to the URL with that myapp:// whatever, and it's being handed directly to the application, which means that your access token has just been handed directly to an attacker, directly, with no way to recover, with no way to detect, because your app's just wondering when it's going to get its token back. It's not like an HTTP call that's going to time out. It sent its redirect, and it may never come back. The user might not say yes, and the app will never hear back. So at this point, the attacker's got your token, and they're having a great day, and you're having an awful day. There's really no way to protect that. The implicit flow suffers from the same problem. If somebody manages to capture the redirect on the implicit flow, even on an in-browser application, then yeah, they get your access token. The good thing about the implicit flow when properly used is that browser same origin policies for JavaScript execution and stuff do protect you to some extent. But in all of these cases, there's no way for the client to go back to the server and say, hey, it's really me, only give me the access token, because the authorization server has already said, well, here's the token. You identified yourself, you didn't authenticate yourself, and that was good enough to get this token. So how can we address this? We're going to use pixie dust. There is an extension to the OAuth protocol called the proof key for code exchange. It's a really clever little bit of crypto, and proof key for code exchange is pronounced pixie, because nerds like cute acronyms. And Pixie is really kind of clever in its simplicity. It only works for the authorization code flow, but it works for the authorization code flow for public clients, clients that don't have a client secret. So, like a native application, or an in-browser application that's using the auth code flow. So what happens is the client starts the front channel redirect, but it's going to generate a random value, it's going to hash that value, and it's going to send the hash of the value over to the server. The server is going to see that, and it's going to remember that hash. That was part of the initial request. And it's going to send back the authorization code, just like it always does, back to the client. But now the client is going to send its client ID, but it doesn't have a client secret anymore because it's a public client. So say it's a native app, and it's just the same copy of the native app everywhere, or it's an in-browser app, and you're doing a, it's just JavaScript that got loaded, that's got the client ID just baked into the JavaScript. Well, now, that instance that made that initial request, well, the hash might have been known by somebody in the middle, because that got sent through a redirect, and who knows who read that. But nobody's going to know the original secret that we used to generate that hash. So when we call the token endpoint with our authorization code, we're going to send that original secret along with it. So we are now authenticating not the client as a piece of software, because we don't really have a good way to do that. We are authenticating the specific instance that made that initial request. So assuming some continuity that the user can recognize that, yes, this is the application that I'm using and it's doing what I expect it to, then the attacker can't steal the access token. Because even if the attacker steals the authorization code coming back, they can't submit it. They don't have access to this, to the PXE verifier. They don't have access to that secret because they can't reverse the hash. And then the authorization server is going to take that secret, hash it again, because it's a deterministic hashing algorithm, and compare it to the hash that it had before. And if they match, then it's going to generate the access token, and everybody's good to go. This kind of stuff was not in the original OAuth2 protocol because it was decided that clients really couldn't do crypto. TLS was going to be the only crypto that was allowed. And it turned out that really shot us in the foot in a lot of ways, native applications and browser applications especially. But I'd like you guys to think back to the years 2010 through 2012 when OAuth2 was being written and ratified. Native apps and in-browser apps, apps that are completely and entirely in the browser, a lot less of a big deal back then. Today, you'd be hard-pressed to find stuff that doesn't run in this way. So a lot of things do this. So we're moving into a different space that OAuth really wasn't made for, but there are some additions to OAuth that help it to live in this space a little bit better. And PXE, I think, is one of the most important ones out there. So all of these different grant types, yes? Yeah, so that is, exactly. So thank you for bringing it back to the summary, and that is that my advice to developers working on in-browser applications today, and there's a chain of more specifics, but is that you really should be using the auth code flow instead of implicit, and you should be using PXE with it in order to tie it to your specific application. You should also always use the state parameter, always use random values for your state parameter, and there was something else I was going to add there. I don't know, some bit of important security advice.
In that flow, do you also get client credentials and also get refresh token?
That's a great question. So it was, do you have client credentials and do you get a refresh token? You can get a refresh token with the authorization code flow because you have authenticated at least the instance of the client in some way. You don't get it with the implicit flow because it was all in the browser. So even if you're doing auth code with PXE in the browser, yeah, you could get a refresh token and then put that in local storage or something. Local storage leaks like a sieve. It's not necessarily the best place to put secrets, but it's an option. People have done worse things. But for native applications, absolutely. You get your refresh token, put it in the platform secure storage locker, and you're in really good shape. You've got a good user experience because the user onboards it once and it just keeps working. They don't have to keep re-entering their password or feel like they're constantly logging in, but you're also protecting them. I'm sorry, I don't understand the question.
See, the PXE solves it for the authorization. Right?
Yeah, for the PXE solves this for the authorization code.
Still not for the access token, right?
What do you mean it doesn't solve it for the access token?
Once the authorization code has been shared back, right? Let's say the access token is also going to be a redirect only, right, to the app, the native app.
No, the access token is not on the redirect. The access token, it comes in the back channel call from the token endpoint directly to the application because you're using the authorization code flow. Right. So PXE doesn't protect that because it doesn't have to. Okay. All right. So we've got a lot of different grant types. They all have their own little kind of niche. And one of the things that a lot of people ask me is that when I'm looking at all of these grant types, how do I know which one to use? So the first question you should really ask, is this client acting on behalf of a user? Are they acting on behalf of a resource owner? OAuth is fundamentally a delegation protocol. The first question you should ask yourself is, who am I delegating for? You should not start with asking, what programming language am I using? That'll tell me what flow to use, or what does my server architecture look like? You want to ask, what are you delegating for? That's your first branch. The second branch is, how can you interact with the user? Can you pop a browser directly? Not do you want to, but can you? So if you can't, but you can communicate something simple, the device code flow is really good for that. If you really, really, really can't, and the user has a very simple set of credentials, that's what the resource owner credential flow was made for. Still has a lot of problems with it, but that is the one tiny slice that maybe it'll make sense for you. These days, I would say, I can't think of a single place where you wouldn't be able to use either the authorization code flow or the device flow instead. I really don't think they exist anymore. And finally, if your client is running completely inside of a browser, maybe use the implicit flow, but I am honestly, as we were just discussing, starting to change my advice based on what's available today. Oh, I remember the last thing, is to use post message to return things instead of URL parameters, which is an option that has been added again to the OAuth protocol. Yeah, you can use post message with a JavaScript client. No, post message, not HTTP post. Yeah, so post message is a browser API thing. It's a WC3. They're bad at naming things. But it is a JavaScript level API that you can basically, you get a JSON blob handed back to the page. It's kind of what it amounts to. So instead of trying to read things off of the URL on the way in, you get stuff as a structured object instead, which is a bit better. What is the whole point? What is the purpose of getting the access token? Oh, thank you. What is the purpose of getting the access token? Well, it's to call an API, isn't it? And here's the cool thing. It's just a regular old OAuth access token. So you could call all kinds of different APIs. I could get your friends list, I could get your calendar, I could get your email, your bank account, whatever kinds of APIs that this authorization server is protecting. But with OpenID Connect, it is guaranteed to protect one particular API, and that is the user info endpoint. Now, the user info endpoint gives us a JSON object that has a subject identifier, which means that the subject identifier that I have in the ID token and the one that I have there always need to match up in a given transaction. But the cool thing about having both of these places is that it allows us to separate information in ways that kind of make sense. So if we go back to older identity protocols like OpenID 2.0 and SAML, what happens with user attributes in both of those? You send the user attributes in the assertion every single time because you don't know if you need them or not yet. The client can't know if it can, the relying party can't know if it needs to request all of the extra user attributes because it doesn't know who the user is yet. It doesn't know if it needs to refresh the profile because it doesn't know if it's even seen you before. The identity provider can't make that prediction either because it can't predict if maybe there's a cache invalidation that needs to happen. So what ends up happening is that the IDP is going to cram all of that information every single time and chuck that across the wire in the assertion because you don't know when you can't do it. OpenID Connect is different because the ID token plays the role of that identity assertion, and that is now able to carry the authentication event information. Here's the identifier of the person that logged in and a signed statement that says this is a thing that happened. If you can then figure out that you want more information, you now need to know their email address and stuff like that, I've got an API for you. You can go call and get that. You can manage your own cache invalidation and stuff like that on a per application basis that makes sense. Additionally, It allows you a more privacy-sensitive way to do attribute disclosure. Really, really important, especially in this GDPR world. You want to know when you need to get users additional information? Well, yeah, you don't want that being chucked around every single application just because you might need it. You're going to be much more careful about that now, and you can. Now, the way that you kick this off is by using scopes. OpenID Connect is built directly on top of OAuth. And so you add the OpenID scope, and there's a bunch of other scopes and additional parameters to get advanced functionality. But at its core, you do OAuth with a special scope, and you get back this JOT and can call a particular API. If you have an OAuth ecosystem and you have access to JOT processing, you've got a 98% of an OpenID Connect implementation right there. And in the long-form version of this class and in the OAuth2 in action book, we actually have exercises that step you from taking a vanilla OAuth system up to a fully compliant OpenID Connect system. It's a lot more straightforward than a lot of people think. I think that's one of the coolest things about OpenID Connect. Because remember that access token, I can call non-identity APIs on it as well. One of the biggest mistakes that OpenID2 and SAML made was this notion that all people are going to care about with this is login. Twitter, Facebook, and a whole bunch of other apps taught us that was completely wrong. We not only want to log in, we want to be able to access other stuff about you that's tied to the platform. We want to be able to know not just your identity, we want to be able to push information back. We want to be able to engage in this API somehow. We want to be able to engage in this ecosystem. Today with Google, they've got a really, really powerful privacy and security escalation model, authorization escalation model, where the first time you log in, it's just, okay, you log in, that's all you get. But then the app can say, oh, can I have your email address? Oh, can I maybe get your location? Oh, can I maybe get this other bit of information? That type of step up that OAuth allows us with the scope model. It's a really powerful way to do things because apps can basically figure out when they need what they need. It doesn't always work all that great in the real world, but possibilities are there. I already ranted about this. Always the tuple of issuer and subject. Never use their preferred username, email address, or the subject alone. And this is what OpenID Connect looks like on the wire. It's doing OAuth with a couple of extra pieces. All right. So we have covered the core of OAuth in detail. We have covered OpenID Connect in skimming detail. Yes? Please. Yep. That is not a dumb question at all. So the question was, when the client gets the ID token, is it consuming it or is it passing it along to something else? That's a fantastic question because, in fact, the client is consuming the token itself. The client is never supposed to pass the ID token on to something else. No, it is not using it in parameters and API calls. It is parsing the ID token because it's a known format, unlike the access token, which we don't know what that might be. The ID token is a known format with structured information in it that is meant for the client itself to consume. So the question is, does the resource ever have access to the identity of the requester? And the fuzzy non-answer is sometimes. Because one of the things that in OAuth is that the resource server needs to know what that token represents. A lot of the time, that token represents, among other things, the identity of the person who authorized it at the start of the whole process. So with that in mind, resource servers usually have a way to look up that kind of information. And one of the things that you can do with that is token introspection, which hopefully we'll have a chance to go for that super quick. But again, we're almost out of time here today. So sometimes they do, sometimes they don't need it, but it is fairly common. But it doesn't, importantly though, it doesn't come from the ID token. It definitely does not come from the ID token, because that never gets passed to the protected resource. Or it should never be passed to the protected resource. I've seen everything in the wild, so I'm no longer surprised anymore. So we talked a little bit about, and I said we'd get back to this whole idea of dynamic client registration. In the original OAuth model, it was assumed that clients would be statically registered by an authorized person in order to access an API, because that's how we did it. You had an API, you either had somebody with a developer account that was creating it, or you had a sysadmin that was generating a record and then handing that to the developers, the results of that to the developers. That's how we did stuff. That's a lot of how we do stuff today. Dynamic registration allows us to do that more programmatically. An instance of a piece of client software basically shows up to the auth server and says, hi, here's a bunch of information about me. Here's my display name, my redirect URIs, all this other stuff. And it's going to get back a unique client identifier, potentially a unique client secret. So this gets around the problem of native applications not being able to ship with a client secret. Well, we can ship them one at runtime. The first time they start up, they say, hi, I'm a new copy of this application, and they get a new version of the client secret. Now, registering does not give the client access to the APIs. They still need to be authorized. They still need to be delegated the authority by some user. So a lot of people get scared of this because traditionally we kind of think that, like, oh, once an application is in the system, it can do stuff. Well, no, the only thing that this application can do is ask for permission to do stuff. And that's exactly what we want it to be able to do. Cool thing is that in the real world, when we're developing servers that support this, we can put dynamically registered clients in a totally different basket from our statically registered clients and say, these guys can only ask for certain scopes. Or, they can only ask for tokens that are good for 1 minute. Or we can put restrictions on them. We can definitely say things like, these guys are not allowed to have the client credentials flow, because that would be really bad, because it's really powerful, and we don't want that to be dynamic. And one of the ways that we can lock this down is using something called a software statement. And a software statement, quite simply, is a JOT that has a whole bunch of the attributes of a client sort of locked down and signed by a trusted authority. It might be the authorization server itself, it might be somebody else. But an instance of a client can now show up with this and say, I'm a copy of this piece of software. This more or less says how I am supposed to behave. These are the grant types that I use, the redirect URIs that I use, all of this stuff. Here it is. And then it comes back with per instance information like a client ID, maybe some other bits of information. The client can't override what's in the software statement when it presents it. It can add additional information, because maybe it's got additional bits, but maybe the admin contact email address is fixed. So anybody that's using this software statement, here's the person to contact when something goes screwy. The other big thing that software statements allow you to do is draw a big lasso around all copies of a particular dynamically registered piece of software. Because everybody that has used a particular software statement, you can note that down in your system and say, okay, everybody that did this software statement, we're issuing a new version of this software statement, so anybody that did this needs to re-register. So just chuck that out, everybody dynamically re-register, and you're on with your day. Now, server discovery is a really kind of a fun thing, and I'm going to go super quick over this, because in order to so registration is all about the server knowing about the client, the auth server knowing about the client. The client needs to know about the auth server too. So how does the client get to know about that? Well, in traditional OAuth space, the developer just looks it up on a web page and types it in. It's great, but it doesn't really scale very well to automated systems, and we've got better ways to do that now. The OpenID Connect pioneered a way to do this, and it's now being adapted into a general purpose OAuth server discovery mechanism. So the way that it works is you take your base discovery URL. In OpenID Connect, this is the issuer URL. Talked about every identity provider is identified by an issuer URL. Well, you take that issuer URL and you add a special URL path to it. .wellknown/OpenID-configuration. Now, where did this come from? Who here has ever heard of robots.txt or favicon.ico, right? Where did those come from? There's these weird files sitting in the root of your server. Well, robots.txt started when early web crawlers needed to be told, yeah, don't screw around with these parts of the site. So they would make a special call to your URL /robots.txt, and they would follow the directions in there. Same thing happened with favicon.ico. It was Microsoft's Internet Explorer back in the day actually came up with a good idea. Like, they're one half of a good idea. And that was take your URL and call /favicon.ico, pull down that image file, and use that as the icon for the favorites, which is what they called bookmarks because they couldn't use Netscape's name for them. Of course, it's the Windows icon format because everybody just uses that as an image file. Like I said, it was half of a good idea. They almost had it. But both of these got dumped into the root of the site. And these things started to proliferate a little bit, and the IETF kind of stood up and said, all right, we've got new protocols that are showing up that are trying to say, oh yeah, do this, put this at /whatever and /stuff like that. So somebody came up with a really great idea of what if we took all of these things and put them into one directory, /.wellknown, and then we had a registry for things that are allowed to go in that directory so that people can find that. This means that if I've got a content management system that's running all this stuff, I'll be able to actually keep this in a certain space, right? I'm not going to go into details of this, but the discovery response has all of the information you would need to talk to an authorization server. Oh, in SAML, yeah. So the question is this similar to SAML's metadata XML URL? Similar, very similar. So now I'm going to talk about token introspection. Now, OAuth tokens are opaque, but they're only opaque to the client. And as we talked about, the protected resource needs to know what it's good for. We've had questions like, does it know, how does it know what user it's good for? Well, there's a lot of different ways to do that. If your authorization server and RS are tightly coupled or even on the same box, then you just look it up. And this was the most common thing to do when OAuth was invented, because you just had the machine that was running your API, and it had the OAuth bits there too. So they would generate an access token and chuck it into the access tokens database table. And then when a request would come into the API, it would say, oh, I got an access token. I'm going to go look it up in the access tokens table and see what it's good for. And that see what it's good for was completely local and proprietary to whatever that application was. So it could be a really complex policy system that would need to get executed. It could just be this user, and that's it. The other thing that you can do is you could pack information into the token itself. Now, we didn't go into the details of JSON Web Token here in this talk because of time constraints, but the JOT as a structured token format can carry information about what it's good for. There are some downsides to that. A large part of that is when the token always says what it's good for, if you disagree as a systems administrator what that token should be good for now, then you're out of luck because the token is going to win that argument because everybody's going to listen to the token itself because that's what you made them do. Or you could have a lookup, and that's exactly what the token introspection protocol is. It's a way to say, somebody handed me a token, I need an adult, what is this good for? And the AS responds with a JSON structure that says what the token status is. And let me see real quick. Yep, no. So unfortunately, I don't have an example of it here, but it's a JSON object that has a field that says active, true or false. And if active is true, you can have things like, what's the resource owner? What's the set of scopes? If you're doing a more advanced protocol like user-managed access, you can have a set of what are the policies that are associated with this. There's a lot of different stuff that you can add to it. It's JSON. It's very, very extensible. And the coolest thing about this is that because it's a lookup, it allows us to get into this trade-off space of how much do I care about the freshness of this information. Now with a JOT, it's all baked into the JOT. It's as fresh as the JOT when it was first minted, and that's kind of it. With introspection, you are paying more for network lookup, but honestly, AS to RS is probably going to be a pretty close and quick connection in most deployments. So not that bad. Certainly not client to RS type of round trips. But it's still kind of a weird cache consistency thing, because when I go look up that token the first time, maybe I get another call with a token a few milliseconds later. Am I going to go look it up again or not? Some APIs, maybe I want to. Maybe this is the transfer $1 million API. Maybe this is the turn off life support API. Yes, I really want to look up every single time to make sure that token is good, because it might not have. That state may have changed in the middle. And I really want to make sure. I'm okay paying that cost. Maybe it's the, get how many friends have liked my picture API. Do I really care if it changed in the last couple milliseconds? I might care if it changed in the last 5 minutes. I might care if it changed in the last hour. But now we've given the control of when to look that up into the hands of the protected resource. Now this is a fine art and a bit of a black art. And this gets into one of my favorite jokes in computer science, which I'm happy I get to end with this, is that there are only 2 hard problems in computer science. Only 2. Naming things, cache consistency, and off by 1 errors. You'll get it. So you're not going to solve cache consistency, but you can at least give things some choice and some tools. Very quickly, token revocation is all about, somebody asked, what if the client decides that the token isn't good anymore? Like, how do I manage how long a token lives? If token revocation is an extension to OAuth that it basically allows a client to proactively say, I'm done with this token. Tell the authorization server, so if anybody else shows up with this token, call shenanigans, because I said that it's not me. So it's a way to have good clients give additional information to the auth server about their state. It's a really simple protocol, not going to go into details. And unfortunately, I don't think we have time to go into all of the advanced stuff of, they changed the order of my screens here. That's fun. Into proof of possession, MTLS, and token binding. There are some talks this week about those topics. Right after my talk tomorrow morning about what is broken and wrong in OAuth2, Brian Campbell, who I teased earlier, you'll also see him all week taking pictures. Awesome guy, engineer at Ping. He's going to be giving a talk about token binding and MTLS binding, which is some ways to do some more advanced security with OAuth and kind of how those works. So it's basically how you move on past bearer tokens. And finally, I'm going to wrap up with 2 things. One, you can find the publisher's page for my book that I mentioned. If you go to oauthinaction.com, or if you Google OAuth in Action, go to the Manning Publications webpage. That's the publisher for this book. Anybody who would like the discount code, come talk to me. I've got that. I found out during one of the breaks, it's actually not a discount just for my book. It's for Manning's entire publication catalog. 40% off their entire catalog, which is pretty awesome. So go check that out. Everything that I covered today is covered in even more detail in that. Also, I am a consultant. I do this as a 2 to 3 day intensive hands-on class. So if that's something you might be interested in, come talk to me. We'll see if we can work that out. I've done it for a bunch of different groups all over the world. And finally, one thing I wanted to land on is that there is, of course, something beyond OAuth, and that is ZZAuth. I am going to be playing with ZZAuth this year at Identiverse at the closing party this Wednesday. Come check us out. It's going to be a really awesome time. You know, food, drinks, great music. Thank you guys very much.